in series Lesson 2 Examples. Before starting the examples, we are having some remarks which are useful for doing the examples. So the first one is 1 minus z inverse, which is expanded as 1 plus z square plus z cube plus z the power 4, so on. Then is the 1 plus z inverse, which is expanded as 1 minus z plus z square minus z cube plus z4, z the power 4. Remember, if we have a positive sign, then alternative signs are used in the series, and if we are having the negative sign, then all the terms are positive. Again, 1 minus z the power minus 2, we are having the negative sign, so all the terms are in positive. So this is equal to 1 plus 2z plus 3z square plus 4z cube up to so on. Then is a 1 plus z the power minus 2. Again, we are having the alternative signs in the series. That is 1 minus 2z plus 3z square minus 4z cube plus so on. Now these expansions, we are having one condition that this is expanded if mod of z is less than 1. Remember this is very important. If mod z is not less than 1, we cannot expand the 1 minus z inverse, 1 plus z inverse. Now to expand this, we must have mod z less than 1. Otherwise, we can't expand, right? Now let's doing example. We have to start with this. Expand 1 over z into z square minus 3z plus 2 for the regions. Now the regions are given to us. First one is z is lying between 0, 1. For the second, z is lying between 1, 2. And for the third, z is greater than 2. Now for these regions, we have to expand. First one is z is lying between 0, 1. So we start from here. For the first, we have z lying between 0, 1, right? And fz is given to be as 1 over z into z square minus 3z plus 2. Now what we have to do is, we have to first make the factors. So this is z, and this is z minus 2 and z minus 1, right? Now the next step is, we have to separate this in fractions. So how can we separate this? I will explain you the trick. Just write the denominators, z minus 2 and z minus 1, right? For the first expression, now putting denominator z equal to 0, I get the value. If I put the denominator equal to 0, I get the value z equal to 0. Put this value z equal to 0 over the second factor and the third factor, leaving the first one. So I get what? I get plus 2. So I write here plus 2, right? Sorry. And now for the term of z minus 2. Put this denominator equal to 0, I get the value of z to be equal to 2. Now put this z equal to 2 in the first factor and in the last factor, excluding z minus 2, right? So the factor we have taken, we have to exclude that factor and put the values for the other two factors. Now what I get? I get 2 here and 2 minus 1, I get 2. So again, I'm having 2 here, right? For the third one, put the denominator equal to 0. I get z equal to 1. So where should I put z equal to 1? In first factor and in the second factor. So I get minus 2. Right? So this is how we separate the we separate the fractional expression. This is, I'm sorry, this is actually z equal to 1. Okay, next I'm writing this step in the next page. So this is equal to, I got 1 over 2z. Then I'm writing for z minus 1 as minus 1 by z minus 1 plus 1 by 2 z minus 2. This is how I separate the fractional expression. Now here, clearly fz is analytic everywhere except z equal to 0, z equal to 1, z equal to 2. Why it is analytic everywhere except these points? Because at these points, the function is not defined, right? The points where the function is not defined, that function is not analytic at that points. So for z equal to 0, first term is not defined. For z equal to 1, the second term is not defined. For z equal to 2, the third term is not defined, right? So clearly fz is analytic everywhere except z equal to 0, z equal to 1, z equal to 2. So therefore, fz has a Laurent series expansion in the given regions for z lying between 0 and 1. First one, we have fz to be equal to this. We got the expression as fz is equal to this. Now what is given to us? Z is less than 1, right? So we have to, alright. From the given remarks, what we are having 1 minus z inverse, right? Or 1 plus z inverse. The expansion for them is whatever may be the expansion for 1 minus z inverse or 1 plus z inverse, we keep in mind that mod z should be less than 1. So here you can see that z is less than 1. Right? So I should make, first term is okay. For the second term, I should make, instead of z minus 1, I should make 1 minus z. Because I have to expand this further. Right? So this is equal to 1 over 2z plus 1 over 1 minus z minus 1 by 2 minus z, which is equal to, here I am having the minus sign, so the sign will change. Z minus 1 becomes 1 minus z. That's why plus 1 over 1 minus z. Now which is equal to 1 over 2z plus, taking the denominator into the numerator, so this 1 minus z inverse minus 1 over 2. Now I should take 2 common, right? So on taking the 2 common, I will get this as 4. So this is 4, 1 minus z by 2, right? Can I take this to the take this into the numerator? Okay, in the next step or in this step only, I will take this to the numerator. So I am taking this denominator to be in the numerator. So this is 1 over 4, 1 minus z by 2 inverse, right? This is equal to 1 over 2z. Expand this. This is 1 plus z square plus z cube plus z to the power 4 up to so on, right? Minus 1 by 4. This can be expanded again as 1 plus z by 2 plus z square by 4 plus z cube by 8 up to so on. Right? Is this clear? So because for this expansion I must write in the bracket as we are having for the first one we are having mod z less than 1, and for the second one obviously this mod of z by 2 is less than 1. See, if mod of z is less than 1, then obviously this mod of z by 2 is also less than 1. Why? Because z by 2 mod is less than mod z, which is further less than 1. So from here I can see that this mod z by 2 is less than 1. Therefore, this can be expanded as this. I can expand this, right? So must write here, whenever you expand, you must write in the bracket the reason for that, which is very important. Now collecting the like terms, this will be 1 over 2z. We are having only one term as 1 by 2z. The coefficient of 1 by z is only 1 by 2 here. There is no other coefficient. Plus, now this is the constant term is 1 minus 1 by 4. Then coefficients of z, which is 1 minus 1 by 8. Right? Then the coefficients of z square, which is 1 minus 1 over 16 z square, so on. Right? So just write the last 1 over 2z plus this is 3 by 4 plus this is 7 by 8z plus this is 15 over 16 z square, up to so on. Hence the result for the first part. Now the second part. Mod z is lying between 1, 2. Now from here, what I get the condition? What should I make which is less than 1? Yes. For less than 1, can I say that 1, I take mod z to the denominator of this 1? 1 over mod z. This is less than 1, right? And from here, I can say that this mod of z by 2 is less than 1 if I take 2 in the denominator of this mod z. So I got two things, 1 by mod z less than 1 and mod of z by 2 less than 1. Again I'm telling you, we just have to keep in mind something of z which should be less than 1, then only we can expand. Right? So here, now on the basis of this conditions, these two conditions, I have to expand. So 1 by 2z can be written as it is 1 over 2z. Now for z minus 1, I am having 1 over mod z less than 1. By making 1 by z in the denominator, what should I take common? I take z common, then only I can get 1 minus 1 by z, because I need 1 by z now. So here, if I take z common, then I get 1 minus 1 by z, which is needed, right? Again for the second one, I have to make z by 2 in the denominator. So for making z by 2, what should I take common? Yes, first I have to change the sign because z is in the first term. So let's change the sign. This is minus and this will be 2 by z. Now it's more easier. I need z by 2. For that I take 2 common again. So this is 1 over 4, 1 minus z by 2. Is it clear? Alright. Now taking these denominators to the numerators as their inverses. So this is equal to 1 over 2z minus 1 over z, 1 minus 1 by z inverse, minus 1 by 4, 1 minus z by 2 inverse. Now open this. This is 1 over 2z minus 1 over z. Now I can expand because I am having the condition to expand this as 1 over z is less than 1. And for this expansion, I am also having the condition z by 2 mod is less than 1. So now I can expand. 1 plus 1 by z plus 1 by z square plus 1 by z cube, so on, minus 1 by 4, 1 plus z by 2 plus z square by 4 plus z cube by 8, so on, which is equal to 1 over 2z this is 1 over z plus 1 by z square plus 1 by z cube. I'm multiplying z inside, and this is minus 1 by 4, 1 plus z by 2 plus z square by 4 plus z cube by 8 up to so on. Now collecting the coefficients. Okay, I'm having the coefficient for 1 by z one more from the second bracket. So 1 by 2 minus 1, 1 over z minus 1 over z square. No more coefficient for 1 over z square. So next now minus 1 over z cube. No more expression further. So it is as it is. 1 by 4. This is 1 plus z by 2, z square by 4, z cube by 8, so on, which is equal to, now 1 by 2 minus 1, this is minus 1 by 2z, minus 1 by z square, minus 1 by z cube, so on, plus, sorry, it is minus 1 by 4, 1 plus z by 2 plus z square by 4 plus z cube by 8 up to so on. Now the last one is for mod z greater than 2. How can I write mod z greater than 2 as? Can I write 2 less than mod z? Yes. Now I need less than 1. What should I write? From 2 less than mod z, what should I write for less than 1? What should I write here? Yes, 2 by mod z. If I take mod z in the denominator of 2, I get 2 by mod z less than 1. Right? But if you take 2 in the denominator for mod z, you cannot get the expression as less than 1. Right? So for less than 1, mod z should be in the denominator of 2. Now fz is 1 over 2z minus 1 over z minus 1 plus 1 by 2 into z minus 2. Now 1 over 2z can be written as it is minus. Why I have taken z to be common here? Because I need 1 by mod z less than 1. See, if 2 by mod z is less than 1, obviously 1 by mod z is less than 2 by mod z, which is further less than 1. So obviously 1 over mod z is also less than 1. Therefore, I make in the second term as 1 over z. Right? Because from here only I get again one more condition that 1 over mod z is less than 1. So therefore, I make 1 over z here because I need 1 over mod z to be less than 1. So here I took z common, and in the next term I take, because I need 2 by mod z. So for 2 by mod z I should take z common. I get 2 by z, right? Now I can expand this. First I have to take this to the numerator as their inverses. So I have taken, then 1 over 2z minus 1 by z, expand this, plus 1 over 2z expansion of this, which is equal to 1 over 2z minus, multiplying 1 by z inside, I'll get this. Then multiplying 1 over 2z inside, I will get this. Now collecting the terms, the coefficients for 1 over z. So from first I get 1 by 2, then in the second bracket I get minus 1 plus 1 by 2, 1 by z. So this is a coefficient for 1 by z. Then collect the coefficients for 1 over z square, then 1 over z cube, so on, and you will get the result. So this is how we solve the Laurent series expansion. We just have to keep in mind again and again what we need in terms of z to be less than 1. And on the basis of the given part, right, we have to make z in terms of z, what we have to make that to be less than 1, right? And on the basis of those conditions, we have to expand the series. We have to expand. So thank you for watching this video. Furthermore, in the next lesson also, I am doing the examples. So keep watching and do subscribe so that you can get the latest videos on this content. Thank you. Goodbye.